Hi, this is Group 3 from SCR515, and we're here to present our Sprint 1 for our whole project, which is going to create our own robot called Anthem. And this sprint goal is to have a virtual robot that can move manually on the map. And basically, we have two user stories in this sprint. And the first one is to use a URDF file to create our virtual robot model, which is fully implemented already. And our second one is to move our robot manually, and it's partially done, but the robot can move, but it cannot move up as our expected. We're gonna show you in the demo, and our GitHub it has a code how to set it up. And see, this is our robot model showing the RVIZ and the gazeable, and Jordan is gonna tell you more about the URDF file.
Okay, so in this Sprint 1, I mainly focus on how to build our own robot model. So I use the USDF file format to describe the robot physics structure. And for now, I already defined two wheels and one caster wheels. And also I defined the inertial measurement unit, which is a device that we can measure and report specific gravity and angular rate of our robot. So Jiayu will do more introduction about movement and simulation in Gazeable.
Okay, sure. So basically, yeah, we're tasking user story to want to manually control a robot. So what we have found is that there is a topic called command velocity. So what we're going to do is to open a new terminal and use Rust to publish command to send a message, including the velocity and angular. So here we paste the command and enter. Yeah, so he's sending a message. What we can see is that the robot has manually moved in the gazebo, and we can also see that the wheel is rotating in RVIZ. Well, we partially done the movement, and we need to do a lot of things in the next session. So maybe Matt can clarify that further. So please.
Yeah. So, like Jayu explained, we are working with the topics right now, which is command velocity, right? So, what right now what we're doing is we're giving it a fixed value. That's why the robot is moving in a straight direction with a fixed velocity. What we want to do forward is have a keyboard input to the rover, which can give it direction and velocity at the same time. Right now, we are still figuring out how we can more easily do it. We are in the process of writing the subscriber and publisher code for this specific topic. And going forward in Sprint 2, we should be able to completely finish this. Leslie, burn down.
Yeah, so this is our burn down chart for our Sprint 1. As you can see, we finished our user story 1 and partially user story 2, and this is our backlog. And then Matt's gonna tell you our business value and our conclusion.
Yeah. So according to our customer expectations would be to have a completely set up virtual robot, and that we have achieved that right now, as you saw previously. The only drawback right now is that we are not being able to completely control the robot, which like I said before, we should be able to complete going forward. Right now the customer has completely seen our fully assembled virtual robot, and a little hiccup here and there, but we should be okay going forward. In conclusion, like I said, we have had a productive sprint. Even though we have not completely finished our user stories, we have learned what we have to do, and we have understood what to focus on going forward. We have understood how to work with our teammates better so that we can finish our stories and tasks going forward more efficiently and in a given time. Thank you